Alright, welcome to 10.3. This is the circle. And the circle is based upon the distance formula. So the distance between any 2 points x1, y1, and x2, y2 is found by using this distance formula. And so he gives you a couple examples of using it. And essentially it's just the subtraction of the x's and the subtraction of the y's. If I showed you a picture, I don't think he has a picture, it will make a whole lot of sense. So if we were in the plane and I would just pick two points. This is the point x1, y1. And let's pick another one up here. This is the point x2, y2. If we want to find this straight distance that's between them, then we can utilize these other distances right here. And because I can, let me make them in a different color. I'm going to make this horizontal distance red, and I'm going to make this vertical distance green. Well, you know that what we just formed is a right triangle, and so what we're after is what I'll call D. So if we need D, what we know is D squared is equal to A squared plus B squared, right? The other two sides squared. Well, what's this red length down here? Let me go back to red. This red length down here is simply the change in the x, x2 minus x1 squared. And then plus, and then what's the other distance in green? That would be y2 minus y1 squared. Whoops, I got off to the side there. y2, let me do an erasing there, because I think this is important that you don't just think that somebody made this up. Whoops, switch over to the pen. y2 minus y1 squared. And so what you're getting is D being solved for. The reason why it's only the positive square root is because it's a distance. And so you can see the distance formula being applied. Not a great grandiose thing for us. So the standard form of a circle is it's the points that are an equal distance away from a center point, right? And this equal distance we call the radius. And so that's why we have been dealing with the distance formula, because we care about the distance from hk to xy. So if the distance between a point, so I'm reading right here, let me go back to a different color. I'm reading right here. If the distance between the point on the circle xy and a center point hk, then we can conclude using the distance formula. And what we have is a modification, right, of not a use of the distance formula, where we're replacing the points hk and xy into the formula, and r as well, right, because now we're calling that distance r, and we get the standard form of a circle, right? And so hk is going to be the center and r is going to be the radius. So without going down any further, if you had something that looked like this, now his notation is messed up, and so let me show you where it's messed up. These ones should not be here. These should be arbitrarily x's and y's. So those ones that are down there shouldn't be there. So if you had something that looked like this, x minus 3 squared plus y plus 4 squared is equal to 16, then here's what you'd know. You'd know the center of that circle is at 3, negative 4, right? Are you okay with that? It's x minus h, and the center was at hk, so we're going to be subtracting away that 3, so it's going to be a positive 3 and a negative 4 as a center, and the radius is going to be not 16, but the square root of 16, or 4, right? And so the radius is 4. So let's see what we have to do in the examples. Here they're just going to show it to you as well. It's up to you whether you want to put it in the pure standard form like that. He's just wanting to make sure that you understand where the positive 2 and negative 1 are coming from. And so you can see the work all being worked out here in example 1. The center is 2, negative 1 pretty quickly, radius 2. Example 2, the center is at, oh, that's good, 0, negative 3, right? When there's nothing being subtracted away from the x center point is at 0. And then a negative 3. And the radius, now look what he has here. He has the radius is 1. You know the radius isn't 1. The radius is the square, well, the radius squared is 36. And so what's the radius? The radius is 6, not 1. So that's a mistake that he has in there. Let me get rid of a line in there. And then also let me go and grab a blue pen so it stands out better. So here we have the center point, -6, -5. The radius isn't 4. The square root of 121 is not 4. I don't know where that's coming from. So it should have been a 121 here, a 121 here, and an 11 here. And here the center point is at 0, 0. R squared is equal to 12. That's great. And so sometimes that happens. We get a radius that is irrational, right, in its form. Here's another thing that we're going to have to be able to do in the homework and on the exam. Given a center point and the radius of the circle, be able to come up with the equation. And so you're just plugging things in. The biggest thing is to remember you're subtracting away the -1 and subtracting away the 3. So we're going to be really careful there to come up with x plus 1, y minus 3. And then be careful too not to set it equal to 3, but to set it equal to 3 squared or 9. So that one's done correctly. Here's a center at -4, -1. So it's a +4 plus 1 in the equation. And we're going to square that radius for 4/9. So it gets pretty easy. This is a great one right here, because what we're going to have to do, so what you're finding is, given the center and the radius, you're home free, right? It's 100% like giving you the slope and the y-intercept. You just drop it into the slope-intercept equation and you're finished. There's other equations that we did back with lines when you're given 2 points, and there we used 1 to get the slope. And that's what we're going to have to do here. Here we're going to be given 2 points, and we're not going to find the slope. We don't care about the slope. We need 2 things. We need the center, which we absolutely know. It's 2, 5. The thing that we don't know is what the radius is, and they don't tell us. So we're going to have to use the distance formula in order to come up with the radius. And so you can see that work being done here, where we take a subtraction of the x's and square it, a subtraction of the y's and square it. And this looks a little bit off, doesn't it? If we subtract, darn it, let's take a look at this guy right here. So here we have r. Let's go ahead and follow it to a t. I believe he's right that the subtraction of the x's is 2 minus -1 squared. Subtraction of the y's, 3. So we got to do it in the same order. Well, I guess it wouldn't matter because of the square, but I will model it doing it in the same order. 2 minus -1. And then we need a 5 minus 3 squared. He has something different. So r is equal to the square root of 3 squared, that's right, plus, and we should get a 2 squared. So r squared is equal to the square root of 9 plus 4. Oh, sorry, not r squared. R is equal to the square root of 9 plus 4. So r is equal to the square root of 13. And so it's really root 13 that's there, not 5. That came from something weird, because he's claiming that his y coordinates are -1 and 3. He got a little bit confused there. So it's 13, but we can finish this. And so what do? We realize, well, the center is at 2, so we're going to subtract away the 2, and at 5. And our radius is root 13, and we got to square it. Right, so everything's going to be the same as what he has here, just replacing the 5 with the root 13. And we get x minus 2 squared plus y minus 5 squared is equal to 13. Awesome. So you'll have to do that sometimes. So graphing circles, giving the equation for a circle. Step 1, find the center. Step 2, put an open circle at the center. Start the center of the circle and count out to the left or right, up and down r units, and make the graph as close to circle shape as possible, and as you go through those 4 points. And so here's what he's modeling here in example number 1. He's putting an open circle in the middle for the center. Now where is the center? The center is at 3, 1. Do you see that? X minus 3, y minus 1, 3, 1, perfectly placed there. The radius is the square root of 4, which is 2, so he's going 2 up in the x two out in the X direction, two up in the Y direction, two back in the X direction, because you're going out two no matter how far. And then what's going to happen that he's not able to show, I guess, is the last step is connecting all those dots to make the best circle that you can. You're not going to be graded on perfection. You just get a quick sketch of what that circle looks like. And so, example 2. Here we go. We're going to get the center. The center is at 0. Ooh, he has it wrong. He has it right down here, but it's labeled wrong. It's at 0, -2. Okay, so center's at 0, -2, and the radius, according to the original equation, isn't 3. Maybe we'll make this say that that was mistyped and that should have been a 9. If that's a 9, then we have the right picture down here, and then this one he does show the circle being drawn. Apologize for the confusion and the typos in there, but I think they're easily able to be understood, and so this will help you navigate through the 10.3 homework, but certainly reach out if there's questions or concerns as you get into that homework.